For Couchbase and language integrated query. I am not Martin Esmond. I'm filling in for him. My name is Jeffrey Morris. I am the maintainer of the .NET SDK at Couchbase. And let's get going. So the goal is to learn how to access data using Couchbase Server with the .NET SDK. We're going to focus a bit on Nickel, because that's our next generation of query language that we're going to be using with Couchbase. And there's a lot of other presentations that go over Nickel in much more detail. So I'm not really going to go over Nickel too much, just kind of how to use Nickel within the SDK and what support we have. So the agenda. We're going to go over Couchbase.NET SDK 2.x, some basic data access operation. We're actually not going to go over views. And then Nickel, the SQLite query language for Couchbase. I'm sure you guys have heard a lot about that this week. We'll talk a little bit about LINQ to Couchbase. And then we'll go into best practices and application architecture and abstractions. And then kind of what's coming up next. This is a bit out of date. We do have async and await support in 2.1. So if you're interested in using async, so the task asynchronous pattern with the Couchbase.NET SDK, it is available. And disclaimer, not so much now, but this was written a couple weeks back, and at that time, a lot of this stuff was still in, development phase. Things have been more solidified now. So the .NET SDK overview. So first of all, there's four main components to the .NET SDK. The number one component is the cluster object. So the cluster object is the main, it's the core object that handles all the communication with the Couchbase server. It handles cluster map configuration updates. It handles reference counting of bucket objects that you create. Whenever for example, let's just say you have a 3-node cluster and you add a node to that cluster, the cluster is going to send back a cluster map to the SDK. The cluster object is the one that will actually receive that cluster map and decide what to do with it, whether or not it wants to update its internal configuration or whether or not it wants to continue working as expected. The bucket object is that's your base API for working with the various APIs that the SDK supports. Views, Nickel, and KV, key value pairs over the Memcache binary protocol. The client configuration class, of course, is your configuration. We'll go over that a little bit in not in too much depth. And finally, we'll talk about the cluster helper. And what the cluster helper does is it makes it very easy to use the cluster and bucket objects within a multi-threaded environment like ASP.NET or Owen, or an Owen-hosted service. So I got ahead of myself a bit, but the cluster object, once again, it's a singleton object. Or it should be a singleton object. So in your application, for each application you have, for each process that you're going to run the SDD client in, you should have what you want to do is create a singleton instance of that cluster object. Usually you want to do it at the root of the application, and then you're going to reference it over and over again throughout the application. So for instance, in an ASP.NET application, you'd probably set this up in the global ASAX, or perhaps in an Owen-hosted application you did in your setup class. It maintains the current state of the Couchbase cluster. I talked a little bit about that earlier. And when your cluster changes, it updates. So it's a smart client aware. We call it a smart client. It publishes configuration updates. And it's also a factory for the cluster manager. The cluster manager is a wrapper around our administrative API. So you can programmatically add and remove nodes, force rebalances, and failover, et cetera, from the SDK itself. So the bucket class. So the bucket class is the core class that you're actually going to use in your application. The bucket class is what I call a super API for the other APIs that the SDK supports. Key value pairs over the memcache binary protocol, get, set, insert, upsert. Support for views, so creating secondary indexes using MapReduce. And of course, Nickel, which is our query language that's in development right now, and we'll be releasing with Couchbase 4.0, Server 4.0. Additionally, it's a subscriber, so the cluster itself is listening to the server cluster. The cluster object's listening to the server, the actual cluster, and the buckets themselves are subscribers for any updates. So if a configuration change occurs, the bucket itself is going to be updated. So a bucket's going to hold a reference. So buckets in Couchbase Server, as you may know, they exist across every node in the cluster. Internally, we create connection pools for each of those nodes in that connection, in that cluster. The bucket itself maintains that list of nodes, or that list of resources, so that you can send and receive data back from the client to the server. It also handles serialization, deserialization, and mapping to and from JSON to your actual object, your POCO, so your plain old CLR object, or your dynamic types, depending upon what API you're using within the SDK. It also handles transcoding. So I'm not really going to go over that too much in this, but we do have, we use Newtonsoft for deserialization, serialization. The newer client, 2.1, allows you to exchange that and create a custom pluggable serialization, deserialization layer. So if you don't want to use Newtonsoft, you can go ahead and create your own, say maybe service stack text, something a little faster than Newtonsoft, and go with that. So it's very extensible. Transcoding is the same way. Transcoding, it handles the basically the network encoding of bytes to and from the server. When you're upgrading from, say, an older SDK to a newer SDK, that might be, or if you're using it in a mixed environment with, say, Java, that may come into play, and you may have to create a custom transcoder to handle the resolution between the encoding types. Now, the client configuration class, like I said, it handles the bootstrapping, the connection pooling, and general client behavior. Really what it is it's a way for you to set up your cluster and your buckets in a way that's tuned to your application. So it allows you to tune things like the connection pool, the number of sockets in the connection pool, the max, the min. It allows you to set timeouts, minimize certain timeouts. Say a connection failing, you may want it to fail out faster than the default of 20 seconds, so you may set that to a lower level. It also allows you to override the default configuration that comes with the client uses by default. By default, the client's going to look at localhost. So if you're setting up your development environment, it's really easy to get up and running. You just simply download, using NuGet, you download the SDK, download the packages, start writing code, and assuming that you have a localhost instance of Couchbase, it's really easy to get up and running. If you need to use a custom, let's just say you want to go to a production environment, then you're going to start building out that client configuration. Now, the cluster helper is something that we added kind of out of necessity. So one of the things is with the SDK is that you need to maintain references for, to have a highly performant application, you need to maintain references to the cluster object, which maintains references to the bucket and the bucket itself. You really want to create, when you start your application, you want to create your cluster object, and then you want to open your bucket. And then you really want that bucket instance to live the entire lifespan of your application. And then when the application shuts down, you want it to close its connections, close its resources, and shut itself down. What the cluster helper does is it creates a singleton for you. So you don't have to create your own singleton of the cluster itself. Now, it also adds, there's an internal thread-safe collection of buckets. So if you want to open a bucket, it's going to create a multi-tin of buckets. So you can open from a cluster object, you can open as many buckets as you want on your cluster. So it makes it really useful. And they're all going to be cached. They're already going to be hot. All their connections are going to be set. There's no boot up time after that once you get them warmed up and running. It definitely makes life easier because you don't have to deal with things like references going out of being collected by the garbage collector, et cetera. I suggest you use it, especially in an ASP.NET situation. So here's an example. Real quick, here's an example of the cluster helper and setting it up with a client configuration. So first, what we're going to do is we're going to create a new client configuration. Now this is a bit, okay, this is going to give you the default configuration. I didn't, customize it, but it's just a show. If I would have called cluster helper initialize and not passed in the config, I would have the same effect because there is a default constructor. Once you create your client configuration, you're going to pass it into the cluster helper's initialize method. It's a static method off of the cluster helper. From there, you're simply going to open a bucket, cluster helper, get bucket. In this case, I'm going to open the default bucket. And it's going to return back an instance. Now, later on in your application, so when your application is shutting down, you're going to want to remove the bucket and then close your cluster helper. Alternatively, you could just call cluster helper.close. For convenience, in that odd side case, you can remove each bucket one at a time. It's an interesting slide. So this is, no. So obviously this image for some reason didn't show up, but we'll go to the next slide. I guarantee there was a diagram there, and the diagram really just showed that, look, here's your cluster helper. So here's your cluster. Clusters maintain references to buckets. Cluster helper maintains a singleton cluster, and multiple references to other buckets. So one of the things, I fear that the next slide is going to be empty too, but hopefully it's not. So one of the things we did is we created a very consistent return value. So for all the APIs that the SDK supports, for views, for KV, for Nickel, we all have a common return type that inherits from iResult. And what that means is it gives us a very consistent way of checking to see whether or not an operation failed or succeeded. iResult is a very simple interface that has fields for an exception, success, so whether or not the operation succeeded or failed, and actually I believe that's all it's in iResult. But as it goes down, each API specializes, they extend iResult and add specialized fields that make it easier for you to build your applications, debug your applications, et cetera. The SDK in general doesn't throw exceptions. It wants to keep working. And so the whole idea of running in an ASP.NET worker process is that if things fail, the client itself can repair itself. So we tend to not throw exceptions. There are exceptions here, exceptions of exceptions. If you can't bootstrap, you're going to throw an exception. So if bootstrapping fails, we're definitely going to throw an exception. If the current LINQ provider in its infancy will throw an exception if an error occurs, but that may change later. And that's really because of how LINQ works. There's no real way to return anything other than the results of your projection. So like I said, I had a feeling this was going to happen, but this image is not appearing as well. But bear with me. So what query options do you have? So what APIs are available in the SDK itself? So there's the three main, I've talked a little bit about this earlier, but the key value pairs is the bread and butter, right? That's your high performance CRUD operations. Views, secondary indexes, lists, et cetera, created with map-reduced functions using JavaScript on the Couchbase server. Finally, we have Nickel. Nickel's our new query language. And we'll talk a little bit about that in a bit. Importantly, in the latest version, we did add support. So we now have full support for the task asynchronous pattern all the way from KV to views to Nickel. So all our APIs now are asynchronous. I highly suggest you use them, even though they're the newer APIs and they're not quite as hardened as some of our more mature APIs. I suggest you use them because they really do reduce latency and increase throughput in your applications. They're non-blocking. In general, they're non-blocking, and they're kind of the future and the way to go. And they also tie in nicely with the changes that have been made to ASP.NET with respect to asynchronous controllers and et cetera. Unfortunately, that image didn't show up too, so I'm going to jump into a quick demo. So first thing I'm going to show is just basic using the SDK itself. How many people here use the .NET SDK? Show of hands. So quite a few. Are you guys on 1.3 or 2.0? 1.3? Anyone here on 2.0? Go to 2.0. Go to 2.0 as fast as you can. This is all 2.0, so hopefully this is all new to you. If it's not new to you, it may be a bit of a refresher. So what I'm going to do here is I have just a simple console application. Once again, I'm going to use a cluster helper to initialize. So I'm going to use the cluster. Is that too small? Yes, it is. Give me 1 second. It's not going to work. That's not working. So we're going to, bear with me, it's going to be a little small. That's not going to work. So anyways, back to, if it's small, I apologize. So we're going to do, create a cluster helper. We're going to get a bucket, a default bucket. We're going to go through and what we're going to do is we're going to read some input from the console. And this input's actually going to be a LINQ query, or excuse me, a Nickel query. So run it really quick. So we're gonna do select all from travel sample, and we're gonna do a limit of we'll do a limit of 1 here. And oh, there we go. So what this did is actually this ran a LINQ query against the travel sample bucket and returned one record and so return one record. It's a little easier to see. So at the top, there's a simple select all from travel sample limit 1. Ended up returning let's see what the type is, an airport. And the second time I ran a second query, I hit enter. And that's a basic example of using nickel directly through the SDK itself. And here's the code to do that. So the nickel, if you're using nickel with the SDK, there's this concept of a query request. The query request is a wrapper around the nickel API, the nickel REST API. What it does is it takes a statement. It also allows you to chain together any number of any number of options that are available through the SDK itself, so that you can change your statement. So if you want to say you needed to change the timeout, you would simply, let's just say you have a long-running query, you set the timeout, and time span, and you could add, let's just, a longer time span, whatever this is. So you could add a longer time span. Then what you're going to do is you're going to execute it. And when you execute, in this case, this is asynchronous. All you do is you're going to add the async keyword to the signature of the method, and then you're going to add a wait to the wait right before your actual method call using the query sync method. There's also a query method. The query method is synchronous. Once again, this goes back to the iResult object. If the result is success, you're going to run through each and run the results of each row using the iResults. The actual, in this case, it's the iQuery result value. If there's an error, then you're going to output the errors. So let me go back into the go right back into the presentation. Okay, so next up is the LINQ support for nickel. So the way that most .NET developers use persistence layers, like say, persistence CRUD operations with a database, say SQL Server or Oracle or MySQL, is using a LINQ provider or some variation of a LINQ provider. So maybe you use Entity Framework, maybe you use LINQ to SQL, or maybe you use NHibernate. Any NHibernate users? I was a big fan of NHibernate. So what we want to do from the Couchbase perspective is, so we have a SQL language, right? We have a SQL-like language. How do .NET developers want to use this language? So we thought, you know what? I think what we need to do is create a LINQ provider. And that's what we did. We started a LINQ provider using an open source framework called LINQ. LINQ is an API that basically abstracts a lot of the difficulties in creating LINQ providers. And what we're doing is we're basically making a way to use the LINQ syntax for you to use nickel against Couchbase Server from your .NET applications. One thing to note, which is different if you do take a look at this, is, like I said, the errors are unhandled, so they will stop. They're unhandled. They will float up to your application tier, so they may stop the process. So you need to wrap them in exceptions. Results are mapped to POCOs. LINQ itself. So if you're using query request API, you're going to want to use dynamic keyword. It makes it much easier to handle the output. However, if you're using LINQ, you got to have a strongly typed thing to do your projection. You need a strongly typed object to do your projection. Now here's an example of a simple LINQ query. In this case, from R in bucket, iQueryable. So iQueryable is the extension that we've added on top of the SDK. Route, select R. So what's a little different about this is the bucket itself is going to represent, well, quite literally your bucket, your Couchbase bucket. When you run a query like this, what this is saying is select all from that bucket, okay? Even though I have a type here for LINQ support so I can do my projection, it actually is going to go through and try to get everything in the bucket. So you're going to end up with a very big response. They probably will not map directly to route in case you have different types of documents in your bucket. What was that? Right now it depends. In general, right now it depends because it is it's a very, I should say, new project. But in general, if there's a field that matches anything, it'll actually, so if you have a name field, they happen to have a name field in your route document, and you happen to have a name field in your airport document, and they both are on the same, your types for route and airport have that name field, then you will get back the name field. But it may not be what you expect, right? So your route may have a name of LaGuardia or something. This is an example of what it emits, just a simple query. Like I said, what you want to do is you're going to want to add a little more, add something that specifies the actual document to return. And on top of that, you're probably going to want to limit the size of your results coming back. And then possibly you may want to distinct them so that you get a distinct set of rows. The query for this is going to look like this. So this will generate a nickel query that looks like this right here. The query request object will then fire off, execute against the server, return back your result set. The result set will then be parsed and returned back to deserialized into your POCOs, or your domain objects. Current support. So as of last week, select, from, where, order by, limits, offset, distinct, and explain are all supported. The asterisk for explain, if you know what, so explain gives you the query plan. Very useful for debugging. The problem with explain in a LINQ provider is the output of your LINQ provider is defined by, if I go back a bit, it's defined by what you have here, right? Because that's what you're going to map your results against. Explain is going to give you something that looks nothing like a route. And so while it does support the explain method, you can't actually execute it using the LINQ provider. You'd have to go in and do it manually at the moment through a query request object. So what are we going to support in the future? Right now, we're looking at joins. Will be the first kind of additional feature we're going to add in. And then later on, nest, unnest, which are nickel-specific keywords. Nest being create a nested document from a flattened document. Unnest being unnest being create a flattened document out of a nested document. Support for having and group by, and then some more nickel-specific keywords like satisfies, every, within, and eventually the full set as much as we can go. What you'll see, though, is where I have a LINQ equivalent keyword, there's not keywords for every single nickel keyword or expression that it supports or feature that it supports. So we're adding extension methods. So most of these will be via extension methods, so you have to use method chaining to access them. So quick demo. Quick demo here. So first I'll show you the code. So this is the same code that we had. This is the same code that I showed you in the last slide. Basically, what we're going to do is build a query, and from R in bucket.queryable with a generic route, where r.type equal to route, we're going to select r.airline. So it's just going to select that one field and map it to the route.airline property. And then we're going to take 10 of these and output them. There we go. If you guys can see that. It's not very bright. There's your 10 items. So those are the 10 airline names, or airline names. So next I'm going to go just a little bit into best practices and application architecture and abstractions. I kind of went over this a little bit in the beginning. But I'll go over it in a little more detail, and then I'll go over a reference application that we have up in GitHub for building an ASP.NET application using a repository pattern. So if you're going to use this, we're assuming that we're going to use Couchbase as our domain, as our persistence backend. There's a lot of questions you need to ask yourself. Do you want to embed Nickel directly in the UI layer, for instance? Do you want to build your queries in the UI layer? Do you want hard or loose coupling of your Couchbase SDK? So in other words, do you want to expose it your application tier, or your controller tier, I should say your controller? Do you want to actually expose your the Couchbase SDK? Maybe you don't. Maybe you need something that's a little more persistence agnostic. In that case, you can use patterns such as a repository pattern, or data access pattern, or data DTO, DAO pattern to create an abstraction layer. I'm sure everyone here, how many people have heard of repository pattern? If you do .NET, you've probably heard of repository patterns. It's very popular the last few years. Martin Fowler says, right, it mediates between the domain layer and the data mapping layers using a collection-like interface for accessing domain objects. In practice, it tends to be a little different. You start adding things like write functions and such. The Microsoft MSDN patterns and practices calls it a abstraction between the the business logic layer and the data access logic layer. Whatever you call it, it is useful for building applications that are consistent and easy to read and understand, and especially for other developers that are going to maintain that software to understand. If you don't like the repository, there are other data access patterns to follow. DTO DAO is one of them. Like I said, in GitHub, we do have a repository Kickstarter using Couchbase as a persistence layer or backend. In it, what you'll find is you'll find an implementation of you'll find an iRepository interface, and then a base implementation of repository. You'll find an iEntity interface, an entity base implementation. You'll see that it does mapping quite nicely between your JSON that you store in Couchbase and your POCO and your application layer. That is the GitHub URL. It's a work in progress, but it's a work in progress, but it's got some promise as a kind of a Kickstarter. If you're going to use the SDK in ASP.NET, it's critical, like I said, that you maintain references to your cluster objects and bucket objects. This is an example in global SAX of how you would set up and start your application. In this case, you create your cluster, you have your cluster helper, and you're going to initialize it in your application start. When the application shuts down, you're going to call cluster helper.close. It's critical that you do this. This is one of the #1 things that I think people get wrong, is not maintaining references to the bucket and the cluster throughout their application lifetime. And I'm going to do a quick, less demo, more a walkthrough of the repository pattern that is up in GitHub. And so first, we're going to look at, God, let me make this bigger. So first thing I'm going to do is, I'm going to show you So this is the actual example application. In it, there's controllers, and there's models, and customized extended repositories, and also views. If you look at one of these controllers, what you'll see is they're very anemic. They're very thin. There's not a lot of logic going on. The logic has been moved over into another layer. At the top here, we have the beer repository that we've defined. I'll show you in just a second. And in the constructor for the controller, all we're going to do is inject that repository and assign it to that private beer repository method. Once again, we're going to reference the bucket from the cluster helper that we initialized in the global ASAX. And once we do that, we're good to go. If we look at our index method, it's very small. This is the index method that's going to run, and this is going to display basically the results of a find. Basically, I'm sorry. This is going to get 10 beers. It's going to select 10 beers and then return them back in a list. This is actually going to be a view definition that does that. We go to the create, and you'll see that we're going to use key value pairs to save using the repository, we're going to use the key value API to save the beer object. And scrolling down just a bit, you should see there's one more method I want to show. I actually don't have it in this example, but I will show you what it looks like in the actual repository itself. So let's jump back to the base repository. So Couchbase.data is the base project, and in it you'll find the repository itself. The interface itself is very simple, very simple. Save, remove, enumerable select. The select takes a query request object, so that's a nickel query. There's also a select overload that takes a iView query, and then there's a find. Going into the repository implementation itself, you will see very simply what we're doing in this example right here is we're going to use the bucket.rem. So let me go to the top. So first, there's a save method. The save method is going to insert a document into the database using key value pair. Remove is going to remove the document using the key value pair. Find is also going to use a key value pair to get a document. I've also added a helper method here, throw if not success. In this case, I want my application tier to handle any exceptions thrown from my business logic tier, my data access tier. Layer, not tier, excuse me. Finally, I have two other methods, and they are select using a SQL query, using a query request, so a nickel query. And what it's going to do is it's going to call the query method off of and pass in that query request object to get the result, handle any non-success situation, and return back the rows. There's also another select override. The select override is going to call a view. Very simple. That's pretty much it. Once you do that, once you have those methods, then you can build. You can extend those. So those are kind of your base kind of repository. Those get you up and running really fast. Now you can do things like extend them and add specialized queries. So in this case, I added a specialized query. I'm going to use an ad hoc query using the query request object. And I'm going to use these name parameters to pass in parameters. In this case, select beer by brewery. I'm going to pass in the brewery, the index, and the limit. The index is going to be the start, and the limit's going to be the number of items to take. I'm going to create a nickel query as a string, and I'm going to pass that in as a query request through the statement. And it's going to return back the results as an enumerable beer list. So there's lots of cool stuff in there. It's like I said, it's a work in progress for sure. So let's jump back into the presentation. And what's coming up next? Possible reactive extensions for .NET. That's something we've looked into. Anyone here into reactive programming? Right here? Yeah, so we are thinking about adding reactive extensions to the client itself. I think it's going to happen. The LINQ to NCL provider, the LINQ provider that I did show examples of, which is just in the very kind of infancy, it's going to be, at some point, we're going to turn that into a full-blown provider. That's the goal. And here's the resources. If you would like to get a little more in depth, get a little more knowledge here, the .NET SDK can be, the source code is up in GitHub. The LINQ to Couchbase provider is also in GitHub. If you want to contribute, the LINQ to Couchbase provider is something that's in early development, so it's a great opportunity to contribute to an open source project. NCL installer goes away with Couchbase 4.0 because you no longer have to run the NCL query engine as a separate process. Also, there's an Azure setup guide that we have. So if you want to host Couchbase in Azure, this is something that's going to help you get up and running. We have a lot of experience running in Azure, and a lot of experts on board that can help you out. A lot of their knowledge goes into this documentation. It's very useful. So there's key takeaways. Couchbase supports advanced query with NCL. LINQ support, it's there. We're working on it. It's getting better every day. Async and await is now supported. Were you guys all waiting for async and await, for asynchronous? It's important. It really is. It makes for a much more responsive application. I'll give you an example. I was getting the 1.3 SDK gets around 4K ops per second. I've seen as high as 50K with async and await on 2.0. And of course, that's in a special environment, but still, that's still a lot better, much better. Once again, any questions?
So if you're using inversion of control with something like inject, do you still recommend using the cluster helper to manage the singleton, or just use scoping to manage the singleton?
Okay, so the question is, if you're using inversion of control, like inject or autofact, do you still use the cluster helper, or do you use the inversion of control container to inject your dependencies? So there's been mixed results from what I've seen. We've had mixed results with people using the autofact and inject both. I think they both add a lot of complexity. You get the same effect by injecting it. You're still using DI, right? You're still using parameter injection, and you get the same result. You don't have that complexity of setting up your autofact and initializing your autofact or your inject IOC. But if you want to do it, you want to try it, definitely. If you run into issues, hit me up on forums. I'll try to help you. If you find best practices and you want to document those, I'll work with you to get a blog out or something. So they're definitely interested in that. Any other questions? All right, guys. Thank you very much. Appreciate it.